All right, so this is our day 5 and so exciting. We are kind of at the halfway point, right? And what we will do is today is the day when we build an app. So today we are going to be building an app called Pong. And this is to continue our learning and applying concepts of animation to build animated games, for example, with image sprites and canvas and timer events of a clock, etc. Let me show you what this game looks like, and then we'll start coding. So I'll show it in the emulator. Yeah, so basically the aim of this game is to just deflect the ball with a paddle, okay? And when I start the game, you'll see what I mean. So the ball, when it reaches the bottom edge, it's game over, okay? And each time I hit the ball with the paddle, I score a point. Now, one interesting feature that I want to introduce today is how do we use a database? So databases are they are an asset in the IT world, right? And we use databases to persist data. So today we'll be showing you how to use a database in your App Inventor app. So that's the exciting part of today's presentation. All right, so let me end this game. And let's get coding. So today this is probably going to take up all of our 1 hour and perhaps a little more. There's a lot to do. So let me start by deleting all this code. Actually, what I could do is move it all to the backpack here. Give me just 1 minute while I do that. And then I'm going to delete everything over here. So all the code should disappear. I think that should do it. Get rid of all the code. That's it. Starting with a blank slate. So as we have done before, I'm going to go really slow as I can. And please use the chat box or unmute yourself and stop me if you have a question, okay? Okay, so let's get started by first building out the screen. So what we have here is we'll start with the horizontal arrangement. So I'm going to the layout drawer, grabbing a horizontal arrangement where I will put the buttons and the checkbox, etc. So from the user interface drawer, I'm going to pick a text label that will show the score, a button to start, a button to reset, one button to, and a checkbox. Okay, so the checkbox may not be visible, but it's there as you can see from the components panel. And what I will do is I'll just change what the text label shows to score. 0. I'm going to change that button to say score, all caps. I'm going to change this button to show reset. And then the checkbox that really mutes the sounds, right? The sounds in a game can get really annoying. So if the player wants to mute it, then that's what they can use the checkbox for. I'm going to make this a little better by going to the horizontal arrangement and changing its width to fill parent. So it's going to take up all the real estate. And I'll also change the horizontal alignment to center. So now the text label, the buttons, the checkbox, they're all centered in this horizontal arrangement, okay? The next thing I'm going to do is the animation component. So what do we need for animation? We always need a canvas and sprites. So from the drawing and animation drawer, we've done this in the last game, Mole Mash. So just like before, I'll grab the canvas, drag and drop it to the screen. Before we proceed, I'll change the height and width of the canvas to take up all of the available real estate on the screen below the horizontal arrangement. And for Pong, I need a ball and I need a paddle. So I'm dragging and dropping a ball and an image sprite onto the canvas. Now this doesn't look like much, right? So the advantage you have with the starter app is that you have all these graphics and MP3 media files that we can use to start making this look more like a game, right? And so let's start with the canvas and change its background image to something like this. Let's also grab the ball and make it a little bigger. So a ball has an attribute radius. All right, so I'm going to make it a little bigger. It was 5, I'm making it 15. So there it is. It looks pretty good, right? And the paddle, it doesn't have an image yet. So let's go to the picture property of the sprite and grab paddle icon, I think it is. No, that's not the right one. Paddle.gif, there we go. Okay. And notice as I move this paddle around, when you look at the properties panel, the X, Y, and Z coordinates are changing. So just keep an eye on the Y coordinate of the paddle. If I move it all the way up, it's going to be a smaller number closer to 0. And if I move it all the way down towards the bottom edge, it's going to be a bigger number, like it's showing 307. So this is one way to, at the start of the game, where do we want these components to be positioned? So this is one way to do that. We can also do this in code. All right. So I think this is good enough to get started. And there's only one other thing I'm going to do. There's button 1 and button 2, and I might forget which one is score and which one is reset. So I'll rename them to be a little more descriptive. So I'm going to call this one start button. I'm just going to the component in the components panel and clicking on the rename button. We'll call this reset button. Let me also call the ball and call the image sprite paddle sprite. Okay, I think I have everything I need. Let's also add a sound component. You can see it below the screen here. What else am I going to need? We'll need a database, but we'll come to that later. I think we're good to go. So let's start coding, okay? So in the first step, what I want to do is I want to have the ball moving from the top edge of the screen towards the bottom edge. And I want the ball to move at a random heading. Now, if you recollect from the last session, the way we do this is use 3 properties of the ball, right? These are speed, interval, and heading. So what I want to happen is when I click the start button, actually, why did I call this score? It should say start, right? There we go. All right, start button, reset button, okay. So when I click that start button, the ball should start moving from the top edge of the screen towards the lower edge. And in which direction should it move? So that will be the heading. So let's start coding this, and this action starts when I click on the button. So going to the start button, I'm going to get the click event of the start button. And by now we have used the click event of a button many times. So within this, what are we going to do? We are going to go to the ball. And we want to set its speed, heading, and interval. So I'm going to grab the setters for these properties. So set the ball speed, set the ball heading. It should be in here somewhere. And set the ball interval. So remember from the last session, the speed is the step that the ball will take in number of pixels. The interval is the time interval in which it takes that step. And the heading is the direction in which it moves. Okay. Let me start with some numbers and we can change them later if needed. So let me set the speed to 5. So it's going to jump 5 pixels every 20 milliseconds. Millisecond is a thousandth of a second. And heading. So what I want to do here is I want to have the ball move at random in this cone that I'm drawing with the mouse, right? So think about compass directions. You have north going up, you have south going down. So this is southwest, southeast. Let's find the numbers for those. So if you remember, the heading is specified with a number and the compass direction north is 90, west is 180, south is 270 and so on. So what I want is a cone, southwest by southeast, and I want to pick a random heading for the ball every time somewhere in this cone. Okay, so what I'm going to do is I'm going to add 45 degrees to 180. So let's say 225, that's southwest on the compass. Okay, and I'm going to add 45 degrees to 270. So that's 315. So that's roughly over here. Okay, so southwest by southeast. And so I'm going to pick those two numbers. Where did this pop up from? Okay, I'm going to pick those two numbers, 225 and 315. And what do I need to pick a random number? So go to the mat drawer, and we know this by now. Pick the block for random integer, and this will be 225 to 315. Let's do one more thing. When I go to the ball, I see that it's enabled, so it will start moving as soon as the app launches, right? But the speed here is 0. So I need not worry about that. But just to be sure, let's disable the ball and let's enable it in this procedure. So go back to the ball and pick the enabled property. Pick the block to set the enabled property. So after the speed, interval, and heading are defined, what do we want to set the enabled to? We want to set it to true. We'll find that in the logic drawer. All right. So let's go back to the emulator and see what this does. So now when I click on the start button, the ball should start moving. Okay, and there it is. All right, so it moves, it hits the edge, and then it just falls to the bottom and stops. So we'll fix that as we go, but at least it's moving now, so we are good. Any questions so far? Okay. There's one other aspect here that I need to include in the callback, which is where does the ball start from? So the starting position of the ball, I position the ball towards the upper edge and on the center line. Let's also do that in the callback of the start button. So what I'll do is go to the ball and pick the set method for the X coordinate and also pick the set method for the Y coordinate. So the X coordinate will determine where I'll find the ball between the left and right edges, and the Y coordinate will determine where I'll find the ball, where I'll locate the ball between the top and bottom edges. Yeah. And we always want the ball to start out from the same place. So that's why We kind of have it covered by positioning the ball here on the screen, and this X and Y, they are not going to change, right? But just to be sure, let's also do this in the callback. So every time we launch the app, the ball starts in the same position. This is going to be a Y. Or starts from a predictable position. It may not be the same position, depends on how we program it. And so the X is going to be the middle of the canvas, right? So we are going to need the property of the canvas. We are going to need the canvas width. Just take the height. We need this one. It's the center. We need to get the canvas height. We change it to width from the drop down menu. What I want to do is to have the ball starting from the middle of the canvas. So that's kind of the width divided by 2. So divide the canvas width by 2 and position the ball there. Y I can set to a small number like 0. Now this will just ensure that the ball always starts off from here. Okay. All right. So now we have the ball moving. We've programmed the motion of the ball, and it's always a random heading. So every time I refresh the screen and press start, it's going to head off in some random direction. Okay. Let's also program the movement of the paddle. All right. So what do we want to do with the paddle? What we want is that when the player drags the paddle with the finger, it should move horizontally. Okay. So it should only move in the horizontal, along the horizontal axis. So how do we do that? So we need an event associated with the paddle sprite called drag. So drag is an event which kicks into action when the player touches the paddle, touches the sprite, and then moves it with the finger on the screen. And so what we want should happen here is that this should change the location of the paddle along the horizontal axis, the x-axis. So paddle has a nice method that we can use. Sprites have a nice method that we can use to do that. That method is move to. So we'll call that method. And this method lets me move the paddle to a new location with the specified x and y coordinates. So think about this for a second. If I want the paddle to just be confined to move horizontally, what should the x coordinate be? So the x coordinate should be the current place where my finger is on the touch screen. And that is the current x. So if I hover with the mouse over the current x, then I get the get x, okay? And that's what the x coordinate is going to be. So it's going to just move along with my finger. Now the y, my finger can also move up and down and left to right. Only the movement along the horizontal axis should register. So what I can do about that is fix the y, yeah? And what am I going to fix the y to? Wherever I drop the paddle on the screen at the beginning, okay? So what this y is going to be is actually just the y coordinate of the paddle, and we are not going to change that. So we're telling it to just keep the y coordinate fixed and update the x coordinate. Do you see the y coordinate? Here it is. So what's happening here is as the player drags their finger across the screen, both the current x and current y are continuously updating, right, as that finger moves. We're grabbing the current x and moving the paddle to that location between the two vertical edges. And we're keeping the y fixed, so it just stays fixed in the horizontal plane. So this is how we're going to achieve just a horizontal constrained movement of the paddle And let's go back to the emulator and test that, all right? So clicking with the mouse button on the paddle, now as I move it, as I move the mouse from left to right, the paddle is just moving left to right. I can move the mouse any which way I want, but the paddle only moves horizontally. All right. So this is a small trick that we use to constrain the motion of an image sprite. There's a question in the chat box. Why divide by 2? Yeah, let me explain that. So why divide by 2 is, what are we doing here? We are positioning the ball with the X and Y coordinates. And what I want to do is I want the ball which resides on the canvas to be exactly centered on the canvas. So the coordinates of the sprite, remember that sprites can only live on a canvas. A sprite cannot live anywhere else. It cannot be outside of a canvas. So the location of a sprite is with reference to the origin, which is the top left corner of the canvas. Okay. And then as I move from that top left corner to the right, the X coordinate increases from 0 to the canvas width. Okay, so whatever is the width of the canvas. So this point here at the top right, X is 0 and Y is Y is 0 and X is the width of the canvas. Similarly, as I go down from 0, 0, and I reach the bottom left corner, what is this point? Yeah, so here the X is 0 and Y is the height of the canvas. So look at where I positioned the ball, right in the center. So what is the center? It is the width of the canvas divided by 2. So imagine we just folded the canvas. Yeah, and that crease where we folded the canvas is where I position the ball. So if I fold the canvas exactly, like we fold our bed sheets every morning, isn't that going to be half the canvas width? So that's why canvas width by 2. Okay. Y is 0 because we want the ball to be towards the upper edge of the canvas. All right. Hope that answers your question. Okay, so now we have both the paddle and the ball moving, but nothing interesting is happening, right? Nothing interesting is happening yet. They just move, but there is no interaction between them. And when the ball reaches the lower edge, it just stops. So let's change that. What we want to do next is, let's make the ball bounce off the left and right edges. So every edge except the bottom edge, the ball is just going to bounce off it when it reaches that edge, okay? What happens when the ball reaches the bottom edge? It's game over. So the game is over. And then the player can choose to start over and the maximum score will be registered. So that's how the game works. So any edge except the bottom edge, right? We want the ball to bounce off it. And when I say edge, I'm talking about the edge of the canvas, okay? I want the ball to bounce off it. And when the ball reaches the bottom edge, I just want to say it's over now. Let's do that next. So in order to program this behavior of the ball, I will use a event associated with the ball called edge reached. So look at all of the events associated with sprites. There are so many of them. There are events that have to do with the player touching the sprite and interacting with it. There are events that have to do with interactions between the sprite and the canvas that it lives on, like when it reaches the edge. And there are events that have to do with sprites touching each other, collisions between sprites, right? And in this game, we're going to use all of them, okay? Or most of them, at least one of every kind. And what we want now is when the ball reaches one of these edges, we want to program what happens next. So I'm going to take the edge reached event and program the event handler. Now, what needs to happen here is we need to detect which edge the ball has reached. Why? Because when it reaches the bottom edge, the game is over. And when it reaches any of the other edges, it bounces off. So there is a dichotomy. So we want to make a decision about what should happen based on which edge the ball has reached. And what do we use to make decisions in App Inventor? We go to the control drawer and we use an if then else statement. And what am I testing for? I'm testing for which edge we have reached. And remember last time we looked at how there is a numeric code for each edge. So the right edge is 3, the left edge is -3, the top edge is 1, and the bottom edge is -1. So this event edge reached is very helpful. It tells us which edge the ball reached, that sprite reached. And then we know the code to interpret from that, to infer from that, whether it's the bottom edge or not. So our test condition is just going to use that edge that the event provided us and compare it with -1. Why -1? Because -1 is the bottom edge. And so if it is equal to -1, all right, if it is equal to -1, then it's game over. Else, what happens? It bounces. Let's program the bouncing bit first. So interestingly, when I go to the ball and I look through the methods, look at that. There is a bounce method. That is so helpful. We can also do this mathematically. It's quite simple. We'll come to that when we look at the paddle. And the bounce method requires the edge, right? So we'll get the edge again and supply it to this procedure. Okay, so what will happen now is when it reaches any edge except the edge called -1, right? So when it reaches the top edge, the left edge, the right edge is just going to bounce off that and keep going. And when it reaches the bottom edge, when edge is equal to -1, what should happen then? Let's just disable the ball. So we've learned about procedures. I'm going to grab a block for procedure and I'm going to call it game over. And all I'm going to do here right now is just go to the ball, find the setter for enabled, it's right up there, and set that to false. So when the ball reaches the bottom edge, it will be disabled. And now that I have made this new Lego brick called game over, where do I find it? I find it in the procedures drawer. All right, let's test our code. Let's see that what we have done here is working. So what do we expect to happen? The ball should bounce off the edges. Let's go to the emulator. Start. Yeah, so did you see that? It bounced off the right edge. So that's working. Let's do that one more time. The first component start. So this time the heading was such that it reached the bottom edge without touching any of the side edges. That can happen because we are picking a random setting, so that's perfectly okay. Uh-oh, I have to restart the emulator. When I do that, any questions so far? Okay, so what we're going to do next is the ball is moving, the paddle is moving, the ball bounces off the edges, but the ball doesn't interact with the paddle. The whole point of the game is to hit the ball with the paddle. So we're going to program that next once the emulator is up and running. Until that time, any questions? Yeah, and while the emulator is loading up, I also want to point out, I've shared this code with you. I do that for every session where we build an app. And so when you look at the code, it may look like you have a bunch of blocks in there. As we keep increasing the feature set of our program, as we keep adding more and more features, notice we are going from top to bottom. Yeah. So pretty much you can start with the blocks at the top, understand what each block does, and just start working your way from top to the bottom when you want to recollect what we did here. All right. Okay, so the emulator is up and running. Let's give this one more chance and see if it does bounce. There we go. Oh, it didn't, oh, there we go. It bounced off the edge in the emulator. The edge was kind of off to the side. That can happen sometimes in the emulator, but yeah, you did see the ball bounce, right? Okay. Next, let's make the ball bounce off the paddle. So now we are going to use the event that's associated with collision between sprites or a ball and a sprite. And that's the collided with. And we have only two sprites in this game. A ball is a kind of sprite. And so when you use the collided with event, you see it's also helpful, and it tells you what was the other sprite that this ball collided with. Now, we really don't want to use that piece of information because we know there are only two sprites in this entire game. And so if the ball collided with another sprite, that is going to be the paddle. But just know that the collision event also tells you very helpfully what was the other sprite that this ball collided with. And what should happen here? So the paddle should deflect the ball. So the ball hits the paddle and then it bounces, it rebounds. Now, for the collision event between sprites, there is no bounce method like we had for when the ball reached an edge. Yeah. So here we are going to need to program the math ourselves, and it's fairly simple. Reflection is basically you subtract the heading from 360 degrees. So it's only one line of math. So, and we are going to implement that. So what we're going to do is we're going to take the heading of the ball as it touches the paddle, and we're going to subtract that heading from 360. So that means it will just bounce off. Okay, so that's how you program the rebound effect. So what do we need to do this? So we need to reset the heading. So we need a set method for the ball's heading. So I'm going to the ball and taking the set method of the ball's heading. And I am going to use the existing heading. So I also need the get method. And we have done this so many times now. We used the get method to get a piece of information, then we use the set method to update it, right? And we are continuing with the same pattern. And the little bit of math involved is a subtraction, simple subtraction from a constant, 360 degrees minus the ball heading. When you look at the bounce method, its implementation is the same. It's just that App Inventor gives us the bounce method, so we don't need to bother with the math. But even when we need to, the math is not simple. I could have used the exact same way to modify, to program the bounce procedure. Okay. So let's test this out. Let's make sure that now when the ball collides with the paddle, it actually bounces off. And that should be an easy test. Let's get started. Bounces off the edge. And there we go. Look at that. Bounces off the paddle. Yeah. The emulator can be a little bit funky. So it's not showing the whole canvas, even though the canvas properties are set to take up the entire width of the screen. And that's just a little funkiness of the emulator that you encounter sometimes. But there you see. Wow. Okay. And I think the speed of the ball is okay too for demonstration purposes. We can speed it up later if we want to. All right. So that's it. So it's bouncing, right? And what we want to do next. So we have the ball moving, we have the paddle moving. The ball bounces off the edges, the ball bounces off the paddle, and we are not scoring any points. So let's now proceed with the procedure to score points, to track the score. What's the game unless we are scoring points, right? Let me just make sure that. There we go. So to keep track of the score, we'll use a similar approach as to how we track score in MoleMash, the previous app that we built. So first of all, I will define a global variable and call it score. So that will be the score in this game. And this block, which initializes the global variable, we'll set the score to 0. So now I've created a variable score. So now my app has memory. If you remember from our discussion on variables, app has a local memory and it can now keep track of the score starting with 0. And what we want to do is in that procedure, track scores, and going to the procedures drawer and minting a new procedure called track score. And in here, I'll write the code to keep track of the score and keep updating it. What I want to do here is every time the paddle collides with the ball, I want to update the score by 1 point. So once again, we get the current score and update it using the set method. So for a variable, like with the attributes of a component, there are get set methods. I'm going to need both get and set. It's a good idea to put all the global variables at the top of the program. That's just a programming practice we follow. All right, going back to my procedure. And what I'm going to do in this procedure is set the global score to whatever it is plus 1. All right, so it's a little bit of math, just an addition problem. All right. So this procedure will keep track of score. And now we have this new procedure and we can use it. Now, where do you want to put this procedure? Now, remember, the score is updated when the paddle collides with the ball. So that's this collision event here. So this is where we want to call the procedure. Remember, when we write a procedure, we have created a new Lego brick. And there is no action until we use the procedure. So we go to the procedure store, find the brick that we just created and plug it into the callback where it belongs, right? So now we should be updating the score, but we also want to show the score, yeah? So to show the score, we have a label. So what we have done so far is we are just incrementing the score, but we are not showing it anywhere, right? So I need to put a little more code into the track score procedure. And what I'll do is I'll change the label, this label over here, to show the score every time it is updated. All right. So again, another get set opportunity here, this time with the label. Where is the label? Here it is. So set the label text property, yeah, to the score, and I want to show the score in a certain way. Okay. Going back to the emulator, I have score, colon, space, and the score. All right. I also want to track the maximum score in any game. So I want the label to show text in a certain way, which I'll get into next. So to work with text, there's a text drawer, and the text drawer has this very helpful function called join, which just strings bits of text together, text numbers, it just strings them together. And what I want is to show, actually, I'm going to put 5 little bits in there, all right? I clicked on this little blue box, which is a configuration box for this particular component, and I want 5 little pieces that I want to string together. Text in computer programming is called strings. And the first string, I just wanted to say score, colon, space. So that's what I've typed in there. And then I want to show the score right next to that, right? So again, I need to, after updating the global score, I need to get the global score and then show it, all right? So far score, colon, space, and it will show the score. You can mix text and numbers together. In this way, it's not a problem. But I also want to show the maximum score, and not computing the maximum score yet, but I want to have a placeholder for it. And I want to show it on the next line. So computers have these codes that they use to interpret things like next line. So next line is indicated by /n, all right? So /n is just telling it after you have printed score, just go to the next line and then print whatever I tell you next. And what is this going to be? It's going to be a max, or let me call it best ever. All right, best ever. And so far, I don't have a best ever score. So I'm just going to show 0. As we conclude today's session, we'll actually use a database to keep track of the maximum score in any game, right? So at that time, we'll come back to this and update it. All right, I'm going to stick this bit into my track score procedure. So you see the benefit of writing procedures like this is I can always keep modifying the procedure to make it do more. And then anytime I call the procedure, these changes will be reflected. Yeah, so I'm calling this procedure only once here. Suppose I were to call this procedure in many different places, I would only have to make these changes in one place. You'll see, we'll come back to that. But yeah, so what I've done now is I've implemented a track score procedure that not only keeps track of the score, the number, but also shows it using the text label. And let's make sure that works. So when the ball collides with the paddle, now it should start showing me the score. All right, let's kick off the game. Oh, I missed it. I can't believe that I missed it in the first try. All right, let's try again. It's not even moving that fast. There we go. So now do you see the label? So look at the top left corner and you see score 2, 3. Every time I deflect the ball with the paddle, score increases by 1. And the best ever just stays 0, right? Because I am not keeping track of the maximum score yet. And then when it touches the bottom edge, the ball is disabled and it's game over. All right. So I have a procedure for game over. If you remember, it has just one line: set ball enabled false. You can modify this and you can show a picture that says game over or a banner that says game over to the player if you want to do that as an exercise, right? But that's kind of why I wrote a procedure game over. You can modify that later to give more visual feedback to the player. Let's do one more announcement now. Let's, so our ball moves, our paddle moves. I can operate the paddle to hit the ball and I get points. Let's add some sound effects. Yeah, what is a game unless it's really noisy, right? So, but it's all about giving feedback in multiple ways to the player, right? And that's why I have all these MP3 files over here. And let's indicate with a sound when the ball touches an edge and bounces off it. Let's use a noink sound when the ball touches the paddle. And let's use a buzzer when the game is over, like, ah, okay? And so what do we need to do that? Do we have a sound component? Yes, we have a sound component. So let's go to the place where the ball bounces off an edge. Yeah, here it is. And here, let's play a sound. So we need to set the source first, and then we need to play the sound. So I'm getting these blocks from the sound component on the coding canvas. And when the ball bounces off the edge, let's play this little note. All right. Actually, if you go to the designer and you look at all these components here, you can actually preview them right here. Right. I don't know if you can hear this, but yeah, there we go. Let me turn it up all the way. It's just a sound like a clinking of wine glasses. If you don't hear it, that's fine. But let's go ahead and yeah, so it's going to play this note and it's going to play it when the ball reaches an edge. I'm going to put that here, clean up these blocks. And then when the ball collides with the paddle, let's play the noink sound. Back to the sound component, set the source. I need that. And then I need the block to play the sound. Same as before. And now I'm going to pick the noink sound and play that when the ball collides with the paddle. Clean up the blocks. And what else? Yeah, when the ball touches the bottom edge. So I can put that in the game over right? So when it's game over, I want to play the buzzer. So I need to set the source to buzzer, back to the sound component, play. This is just repetitive, right? Over and over. Just repetitive code, changing the sound file that we play and just doing it in different places in our code. Right, so just a quick recap. When it's game over, it'll play the buzzer. When it bounces off an edge, it'll play this note dot wave. And when it collides with the paddle, it'll play this noink sound. And let's make sure that that's working. Let me turn up the sound all the way up and start. You can hear the noink sound. I kind of like the noink sound. The note is too faint, so yeah, I can hear it, but I'm not sure if you can. And I think the buzzer is really loud. Yeah. Yeah, I hope you are able to hear the buzzer. Okay, we are more than halfway there, and we've done a lot, right? There's a few more things we have to do, so just hang in there. Any questions so far? You guys doing okay? All right, I'll keep moving. All right, now we come to an exciting part of today's story, which is how to use a database in App Inventor. And although here the application of a database is relatively simple and straightforward, we are just using a database to keep track of the best ever score anytime anyone played the game on this device. But really what you learn here, you can use it to do much more profound, to reach much more profound goals in your App Inventor code. And to use a database, I go to the storage drawer. So first of all, let me just take a moment to explain why do we need a database. I am using a variable and I'm using it to track score, right? So why do we need a database? Anyone want to answer that question? So the reason we use a database in the software world is because when we use variables, variables are really great. They're very fast. They're a very fast way to access information, to store it, to retrieve it, to update it. But the moment the program closes, the moment we close our app, for example, the slate is wiped clean. If you remember Men in Black, where Will Smith has that flashy thingy, and he flashes it and people lose their memory of what happened like for the last 5 minutes. It's kind of like that, right? So the moment we start an app and we are using variables to store information, all of that is fine. And the moment we close the app, it's like the slate is wiped clean and the app has no memory the next time we start it. What happened? It starts with a clean slate every time. And if we want to get around that, then that's when we need to use a database. You see a comment here? Keep info history. Yeah, that's right, Lutz. Good job. So to keep that history, exactly, right? So we won't get that history across different sessions of the app without using a database. And so usually when you use a database in IT, it's a little bit intimidating. Why? Because you need to pick a database technology, you need to download and install the database, and not only that, you need to host it. Okay, and all of that is a fair amount of engineering, software engineering. And even to just use a database that someone has already downloaded and installed, the usual way, the traditional way to do that involves a programming language, you could say, called SQL. That stands for Structured Query Language. And so it used to be that only technical experts, only technical people with training in database technology could use a database, right? And since then, databases have come a long way where they have become more simple to use, especially if all you care about is storing and retrieving data. You'll hear about APIs, application programming interfaces. It sounds complicated, but all it is really is just a way to access a database in the cloud. For example, on Google's server, a server owned by Google, a machine owned by Google with a database on it, from your web browser. Yeah, and if you're interested, I can show you some more about that in one of our officers. And in App Inventor also, they have made it very easy to use a database, as easy as using any other block for, say, a sound component. Okay. And the first thing we need to do is actually grab the database. So your Android phone, your smartphone, has a database already installed on it. And on the Android phones, it's usually a database called Redis. And what App Inventor is doing is it's allowing us to just use that database using blocks. And so when I go to the storage drawer, I see 4 options there. TinyDB is the one that we are going to be using, and that's the database that is running on your phone. Okay. There's also TinyWebDB, which is almost exactly like TinyDB, but it's not running on your phone. It's running on MIT servers. And then there is CloudDB, which also runs on a server in the cloud. So this TinyWebDB, MIT is kind enough to host this database for us on their servers. We can use that in a later app. Today, we are going to use TinyDB, which is just the app that's on your device, okay, on your phone. So when you do this, your results will be different from mine. The data that the database shows will be different from what you see when I do this demo. Naturally, because this component is sitting on my hardware. So don't be surprised if the numbers that you see, the data that you see are different. Okay, and now that I have that component, actually, I dragged and dropped it in TinyDB here. Now I go get back to the coding canvas and I want to track score, right? So first of all, before even I go to the database, let me define another global variable and let's call it best score ever. I like to use these very descriptive names. So the best score ever. And it's just like the score, except like Lutz was pointing out, its history. So I'm not going to initialize this to 0, right? Because I want to pull this number from the history. So I'm actually going to pull it right out of the database. And the way TinyDB works is I can save information and update information and retrieve information using a tag. A tag. A tag is just a text label, nothing more fancy than that. So just like when I take my bags and I go on a flight to the airport, I'll tag it. Yeah, it will have a barcode, it will have my name, some other information. That's all a tag is really, okay? It's just a text label. And so when I go to the TinyDB component, I see a block that says get value. I can also see blocks for store value. So this is what I'll use to retrieve data. This is what I'll use to put data in, get data out. So these are different blocks for doing those operations. And then there are blocks for getting all the tags. If I want to know, if I want to clean house and I want to see, am I using this tag already? What all tags are in there? Because there's only one database on your Android phone, right? And it's a small one. So from time to time, we may need to flush the database, remove data that we no longer want. And since all data is saved with a text label called a tag, I might want to just know what all tags are there and get rid of the ones that I'm not using or get rid of all of them. So for that, I have operations like get tags. It will just give me a list of all the tags that I'm using. Clear a tag that will remove, delete all the data that I stored under a tag, or stashed. I like to call it stash, or clear all, which will just refresh the database. But be careful when you do that, you will delete all of your data on the local database, not just the data that you created using the app. Yeah, we've done that sometimes. So what we want to do now is just get that value. Yeah, and what tag should I use to store the best score ever? I can use anything I like, but let me just call it Pong max score or Pong score. I may already be using this tag, so there might already be a number in there. And the first time I use this tag, there will be nothing there, right? So that's why you have this value tag not there, which means, okay, if the tag is not there, what to do? So usually we developers, we say that the database will croak. Yeah, it will crash my app and it will say, hey, I don't know what this tag is. I've never seen it before. But in App Inventor, that doesn't happen, right? It will give you a provision to return whatever value you like. If the tag is not already there, it will create that tag for you. So it tries to be very helpful. There's a question, is tag the index number? So tagging is a little different from an index number in the sense that it need not be a number. Yeah, it can be any text label. And as long as it is a unique text label, it's fine. I hope that answers your question. All right. So if it doesn't find a tag, what do we want it to return? I want it to return 0. Score is a numerical value. Right. Okay. So now I have a way of initializing the best score ever. Let's write a procedure to update the best score ever. I'm going to start by just grabbing a template for procedure, a blank template, and let me call this track ever. You can call it whatever you like, right? And what this is going to do is when the game ends, it's going to look at the score, compare it with the historical maximum. And if the score is greater than the historical maximum, it's going to update what I have in the database. Otherwise, it's not, there's no need to do anything, right? The historical maximum will just stand. Am I making sense? Yeah. So what I have to do is call this procedure when the game ends, that is the ball reaches the bottom edge. And the first thing I have to do is to compare my score at that exact point, the global score with the historical maximum. And to make this easier now, I've already initialized, I've already retrieved the historical maximum and stored it in this global variable called best score ever. So I'll be comparing score to best score ever. So let me get both of these, right? Get the global score, get the best score ever. And the reason I'm putting these global variables at the top of all these code blocks is that's usually a good programming practice. So you always want to do that. But that does mean I have to drag these components all the way from the top to wherever my procedure is. Yes, and what do I want to do? To compare these, I want an if statement. Go to logic, control, grab an if then else. Let me start with that. What I want to do is check if my global score is greater than the best score ever. So to compare numbers, I go to the math drawer, grab the component for comparisons. I want greater than. Is my global score, when the game ended, is my score in that game greater than the best score ever? And if that is the case, then what should I do? Yeah, I want to update the best score ever, and I want to reflect that in the database. So I need a setter. So let me go back all the way to the top, and I want to set this global variable first to the new best score, right? Oh, I got a getter. No, that's no good. I want to set it now. Okay, there we go. So set the, yeah. So if my new score is better than the historical best, then I change the historical best to the new score. I just duplicated that. There we go. All right. And now I want to reflect this in the database, right? So I go to the database, TinyDB1. Which method do I need to pick? Get value, get tag, store value, store value, right? So databases have this acronym called CRUD, C-R-U-D. And CRUD stands for how do I create data, How do I retrieve data? How do I update data? And how do I delete data? And really, from the standpoint of a user of a database, that's all there is. So whenever you pick a database component, whichever it is out of the four that I showed you, always be looking for, always keep CRUD in your memory and look for what do I use to create data in the database. Oh, looks like that's store value. What do I need to retrieve? Looks like that's get value. What do I need to update? Oh, that's again store value with the right tag. Okay. And what do I need to delete? Clear. So that's a very handy way of wrapping our minds around database operations. There are only four things to keep in mind. Yeah. And now I'm going to update. So I'm going to use store value. So if there's something already with the tag that I provided, and remind me again, what is the tag that I'm using? I believe it is Pong max score. Is that right? Pong max score. I need to make sure to be using the right tag. Okay. And look, it says value to store. So that's going to be now my global best score ever, which I just updated. Are you with me so far? Any questions? All right. Yeah, this is exciting. So we've used a database, and if the score in this current session is not greater than the best score ever, then I don't need to do anything. So actually I can leave this else blank. Another choice would have been to just use the if then, right? Because there's no use for the else, I think. Okay. Yeah, so that's that. Okay, so now not only am I tracking score, I'm also tracking the best ever. And here's, look, here's the track best ever. And now where do I need to call this Lego brick that I just minted? When the game ends, right? We are always looking for the maximum score as the score when the game ends. So here's game over, and I'll call it here. Making sense, I hope. Yeah. So what should happen now is we are keeping track of the highest ever. And the only thing that's remaining is to actually show that every time we update the text label that shows the score. So as a placeholder, we were showing 0. I'm going to get rid of that. And instead of 0, now that I have the database and we are tracking the score with the database, just go back to the database and just get the maximum score. With the correct label on score. And value if tag not there, we can keep that as 0. Okay. Any questions so far? Oh, we've come a long way. Let's, before we celebrate and break out the champagne, let's make sure it works, right? So start. And there we go. So it shows best ever as 18. And that's from all the time I've spent playing this game. Or my 6-year-old has spent playing this game. And so what that means is to check that this is working. We know it's working. We know at least it is getting the best score ever. Let's also make sure it is updating it. In order to do that, I need to score more than 18, right? So you get the pleasure of watching me play this game. And now that ninth sound, it's sort of a hit spot. All right, our long journey is almost over. 19, 20, 24, I can't help showing off, huh? And game over. When I reset, now the best ever should show 21. Oh, reset, we have not implemented reset. So when I click start again, there you go. It shows 21. And for some reason, my current score just kept going up from where we left off. So let's fix that. Yeah, but you see the database component is working and it's keeping track of my best ever score. I'm going to stop this game and fix this bug. So when it's game over, not only should I disable the ball and play the buzzer, I should also reset the global to 0, right? So set global score to 0. Are you following what's going on here? Yeah. So that should take care of that. And if you see any flaws in my logic, feel free to call it out. You see a comment there. If not there, what does it mean? Yeah, I'll come to you in just a moment. This tag the index, we covered that. If not there, what does it mean? I'll come to that in a moment. Let me just make sure that click start. Let's move to 0. This score is adamantly remaining. Ah, there it is. It is okay. So it's resetting. So we got that fixed, right? Just stop this game. Yeah, if not there means that, so when I use a database and I create a new tag for the first time ever, then the database doesn't already have that tag. So there's no value associated with that tag, right? So that's what tag not there does. Yeah. So the first time I create any tag, I could have called this like best score ever, just like the global variable. So when the database sees that tag for the first time, it doesn't recognize it, and there's no value stored in association with that. So if I'm querying the database and I'm telling a TinyDB, give me the value you have under Pong max score. So wait a minute, I have not seen this label before. So that's when it will return value tag not there. Whatever I provide here, it could be a string, it could be string as in text, or it could be a number. But from that point onwards, it remembers that tag. Okay, so there will usually be then a value stored until I clear the tag. All right, so I hope that answers your question. So I think our game is pretty much done. Let me have a quick look at the backpack and see. Yeah, so we need to implement the reset feature and the mute feature, right? And yes, make sure that when the game is over, the ball is disabled, score is initialized to 0. We are already over time, so I'm going to pick one more thing to show you, which is the reset button. Okay, maybe let's do the mute one. That is simpler. All right. Yeah, so what the mute feature does is it turns off all the audio. Okay. And when you look at the code, we have an audio file playing in 3 places. So in each one of those places, what I would need to do for the mute feature to work is use an if then else statement or just an if then statement. And if that checkbox is checked, then do nothing. Otherwise, play the audio. So rather than doing it in 3 places, I can use a procedure to do this in just 1 place. And this is, I want to show this as an illustration of how procedures are good programming practice and how they help. So what I will do is, although it's just 2 lines of code to play a sound, you set the source and then you play. I will create a new procedure that does that. So I grabbed an empty template for a procedure, and I'm just going to call it play sound. And I need to tell it which sound to play, right? So I'm going to take an input and plug it in there. So now it has an input, and I just call it sound file. Just call it file. It's simple. Okay. And in this procedure, what do I do? Grab the components from here, put this back, just cannibalizing these bits of code. Yeah, I will set the source to whatever the file is. So I need to get the file, and then I'll play that sound. Okay, get rid of this. Yeah, so where I was earlier setting the source to note, now we'll just call this procedure. So I go to my procedure store, and here's the procedure to play sound. Note was when we hit an edge, right? Okay, so here we'll play note sound. So our procedure is ready. All we need to do is to tell it which sound to play. Okay. We want it to play note. Well, actually, when it reaches the edge -1, we want it to play the buzzer sound, right? Okay. And when it bounces off an edge, that's when we want it to play the note. So now that I have the procedure, I can use it in all these places. So it touches the bottom edge, it plays buzzer. It touches one of the other edges. I'm going to clean this up. It plays what? Note.wave. To be consistent, let me always have the sound played first before anything else happens, okay? And then there's one more place where we play sound. That's here when the ball collides with the paddle. Could you do this with the procedure? Play sound. Annoying. Did I do this right? Do I have the right sounds in the right places? Yeah, annoying, noted buzzer. Yeah, so far, these changes that I've made by grabbing the blocks to select the source to play and then playing it, it's not affected the functionality, right? So let's just play the game and just make sure that the sound is still playing. Yeah, there goes the noink, very comforting. Everything else is doing okay. All right. What I really wanted to do this for was to enable the mute functionality. So now what I will do is I'll check if the checkbox for mute, that's this checkbox over here. If that is checked, then only I will play the sound. Okay. So I need an if then statement. And what do I need to do in this? I need to check if the checkbox is checked. So I click on the checkbox and check that it's checked or not. So it has a checked attribute to make this easy. If it's checked, that means mute, right? So then I do nothing because then it's mute. So I need an else. Okay, so if checked, do nothing. It will not play any sound. Otherwise, play the sound. So by making this change in just one place now, I have enabled a mute feature. Let's test it out. Start the game. All right. And now let me check the box on the fly. Now it's muted. You see that? It's not playing any sound. Assuming you could hear the sounds in the first place. Let me turn the volume on the way up. It is turned up all the way. Yeah, it's not playing any sounds now. So the mute feature is working. And uncheck the box. And there, the sound is back. Do you hear the ninth sound? All right. Okay, so that's that. The only thing remaining. Oh, it is a bit lazy. I'll just turn it off. It's playing all by itself. It's over. All right. The only thing remaining is to implement the reset feature. So the way this works is once the game is over, I press reset and then start. So when I press reset, the score will be reset to 0. The text label will be updated. And that was the only remaining feature to implement. And it's quick. So what we do is we'll just go to the reset button, grab the click event. And instead of writing a bunch of code here, right, what I will do is now just use the track score procedure that I have already. So what happens in the text score is I update the score and then I show it in the text label, right? What I want to do here is very similar, but not identical. I want to update the score, but instead of incrementing it by 1, because I'm resetting the game, I want to update the score to 0. And then the rest of it is the same, right? I just want to show that in the text label. And another 2 minutes will be done. Okay, so just hang on for 2 minutes more. Yeah, so we need to have this, we want to reuse this procedure. And the whole point of using procedures is that we can reuse code and not have to rewrite the same code over and over in different places. Yeah. But I need to modify this track score procedure a little bit in order to be able to reuse. Specifically, it needs to be able to sense whether it was called from the ball colliding with the paddle, in which case the score will be incremented, or from the reset button, in which case it will be set to 0. So this one line of code that updates the global score, that needs to change depending on where the procedure was called from. So how do we do that? So let's give the procedure a flag. So this technique is called a flag. So as an input to the procedure, we flag whether it came from the reset button or the ball colliding with the paddle. Makes sense? So it needs an input. Let me give it an input, and let me just call it flag. Okay. And now when I go back to the procedures drawer, you'll see track score. Here it is, but now it has that flag, which I need to supply to use the procedure. And I'm going to call this. And before I call it, I actually need to use an if then else. So if flag is true, then it was called from the reset procedure. Actually, let's call this reset flag, okay? Just to make it very obvious that it is true if it is called from the reset button. Right now, there's an error over here because this is still outside of the procedure. So this doesn't know what flag is, okay? But we'll fix that in a minute. Yeah, here, a little bit of a surgical operation here to get the code blocks out. So if the flag is true, so when I call this procedure from the reset button, I'll pass it true. Let's do that right now. Logic true. All right. Yeah, so when I call the procedure in this way, and the flag is true indicates that it's being called from the reset button. What do I want to do? I want to set the global score to 0. So I've just duplicated that block of code. I don't need any of this. I just need the number. I'm going to change that to 0. Off you go. Yeah. So when I call this procedure from the reset button, the reset flag is true and the score is set to 0. If it is called from anywhere else, I want to update the score as I was doing before. I want to increment it, right? And we are almost done. So there we go. Okay, clean up the blocks. There we go. And remember, the reset button is now the second place that we are calling the track score procedure from. The other place is when the ball collides with the paddle, right? Here it is. So here you see this reflects the change that we made to the procedure. So it is asking for the reset flag. And what is the value of the reset flag going to be here? It's going to be false because here we are not calling it from the reset button, right? Yeah. One little change I need to make here is flag is actually reset flag. Clean up blocks. And we are good. Yeah, we're done. So let's go back to the emulator. Let's start the game. And at any time during the game, I don't have to wait for the game to be over. I can hit reset and look at that. The score is 0 because I click the reset button. And to start the game over, I just click start. All right. So, or if the game ends with the ball touching the edge, game over. My score was 2. The best ever score was 32. Reset. And the score is back to 0. And so our app for the day is complete. Yay! All right. So let's do a quick recap. All right. Thank you, Lourdes. All right. And thanks for keeping your questions coming via the chat box. Just a quick recap of what all we did. We started by just, excuse me. We started by just implementing the callback for the start button. So when we click on the start button, this event response, this block of code here, just initialize the ball location. And then it got the ball moving with the speed interval and heading. Remember, this is based on the internal clock that every sprite, including ball, comes with. That's why we don't need an external clock for that. We used a random heading. So with the ball moving, the next thing is we enabled our paddle to move. We want the paddle to just move in the horizontal, along the horizontal axis. So we constrain the y coordinate. Yeah. Location has x and y. If we constrain the y, then the y doesn't change, right? And so it remains horizontal. And we grab the x coordinate from the location of the finger on the touch screen. And we saw how the dragged event helpfully provides that information with a bunch of other information. So now we had both the paddle and the ball moving. We said, let's make the ball bounce off the edges. And to do that, we use the edge reached event of the ball, which is anytime the ball reaches any edge of the canvas. Remember, the ball or any sprite, we really talk about it only in the context of the canvas in relation to the canvas, right? So we use the edge reached event to detect when the ball reaches the bottom edge. And when it reaches the bottom edge, it's game over. We wrote a game over procedure for that, a very simple procedure that disables the ball and resets the score. And when the ball touches any other edge except the bottom edge, we use the bounce method of the ball to just get the ball to bounce off that edge. Okay. And then we said, let's move on and have the ball bounce off the paddle. So we use the collision event, which is available for any sprite-sprite interaction. A sprite can interact with the player, a sprite can interact with the canvas, a sprite can interact with other sprites. So here we use the collision event for sprite-sprite interaction. And we first change the ball heading to get the ball bounce off the paddle. And we wrote a procedure to track the score using a global score variable. And then just using getters and setters to update the score and then show it in the text label. Then we decided this was not enough. We wanted to track the best score ever. And so we saw how we need to use a database for that. If you take nothing away from today's session, just take away the CRUD acronym for a database. What is CRUD? C-R-U-D. How do you create information? How do you retrieve information? How do you update information? And how do you delete information? Any database, as a user of a database, you're always only concerned with these 4 operations. So there's an underlying simplicity to this, which if you remember, using a database becomes really easier, right? Working with database technologies becomes much easier. And so we used a TinyDB component to enable a database in our app. And then we used the get value method and the store value method to retrieve and create or update data. The important thing is for TinyDB, we manage data to store, to retrieve, to update using a unique label. That's the important thing to remember about using this database in App Inventor. And then we saw how procedures are helpful in making changes to our code as we evolve our app in just one place instead of all over the place and losing track of what we are doing, right? And so we wrote a procedure to play the sound, a very simple procedure. We pulled all the code we need to play sound there, and then we associated it with the checkbox. So by checking the box or unchecking it, we can control how the sound is played or not played anywhere in our app, right? So that was to really wrap our arms around how we use procedures. And we got a little more practice with that, with the reset button and rewriting the track score procedure to flag where it is called from and to do slightly different things, variations upon the same set of actions, right? Depending on whether the procedure is flagged, how the procedure is flagged, depending on whether it was called from the reset button or from the collision event of the ball and paddle. So much of learning today, yeah? And it's great that both of you have been following along. Yeah, when we meet next, we'll continue to practice this with the deep dives. And so if there's anything that is not clear, you'll have another opportunity to clarify in the next session coming up next Tuesday. And as always, there are office hours on Friday if you want to take advantage of that. But that is all for today. Hope you had fun. I really enjoy this every time, right? Hope you had fun too. And I'll hang back if you have any questions. Otherwise, we are done for today. Thank you. Have a wonderful
All right,
evening.
thank you.
Yeah, I'll hang back in case there's a question. Otherwise, we are done for today. All right, thanks.